Alright, tonight's homework was dealing with the distributive property and simplifying expressions by combining like terms. Alright, the first set says use the distributive property to rewrite each expression. So I'll work two of these. If we look at numbers 1 and 3, okay, we have 2x plus 7 inside the parentheses, and that entire part is multiplied by 5 on the outside. Okay, the distributive property says that you can take that number on the outside and multiply each piece on the inside by that 5. Remember to not just multiply the first part by 5, but multiply both parts on the inside by 5. So 5 times 2x gives us 10x, and 5 times 7 gives us 35. So what we end up with is 10x plus 35. Okay, we didn't change the value of anything. All we did was change the way that it appeared. We wrote it in a different way. Okay, number 3. It says 3 times m plus n. We can do the same thing. We can say 3 times m. We can say 3 times n. 3 times n is 3m. 3 times n is 3n. We have a plus sign. We're going to bring the plus sign down. So 3m plus 3n. Okay, moving down. It says simplify each expression. If possible, if not possible, write in simplest form. We'll go down the left-hand column first. Okay, the way we simplify expressions is by first identifying which terms are alike. In number 5, 2x and 8x are like terms because they have the exact same variables with the exact same exponents. So since they are like terms, we can add them. 2x plus 8x, the way we add like terms is by adding the coefficients and leaving the variables and their exponents exactly as they were. So 10x would be our answer to number 5. Moving on down, number 7. These are like terms also, 4ab and ab. We can add those because they have the same variables with the same exponents. Remember that if you have a term that doesn't have a coefficient in front of it, that it's implied that that's a 1. So on number 7, 4ab plus ab, or 1ab, gives us 5ab. Okay, same thing on number 9. In this case, we're subtracting. We subtract just like we add. 16m and 10m are like terms because they have the same variables with the same exponents. 16m minus 10m gives us 6m. Alright, 11, doing the same thing. 15i squared minus 15i squared. Well, these are like terms because they have the same variables I, the same exponents 2. If we subtract something from itself though, 15i squared minus 15i squared, we end up with 0i squared. Okay, 0i squared is just equal to 0. So if I put that in simplest form, then my answer would be just 0. Okay, on number 13, now we're getting an extra step involved in there. What we need to do is to simplify by doing the distributive property, and then at the end we might have to combine like terms. Just like we did at the top of the page on numbers 1 and 3, we're going to take that 5 and distribute it to the r, distribute it to the 2. 5 times r is 5r. 5 times 2 is 10, so 5r plus 10, and then we have plus 7r at the end. Alright, we have some like terms. Again, this term and this term are alike. That means that we can add them. 5r plus 7r gives us 12r. And the plus 10, there's not a term that's like plus or like the 10, so we just have to leave plus 10 as part of our answer. So this would be our final answer, 12r plus 10. We know that our expression is in simplest form when we have no parentheses and no like terms remaining. In number 15, we're using the distributive property again, and that's what we're going to do first before we start to do anything else farther out here to the left. We need to say 7 times y and 7 times x. 7 times y is 7y. 7 times x is 7x. So what we end up with is 7y plus 7x. Okay, the 6x plus was in the front. I'm just going to bring that down. 6x plus 7y plus 7x. Okay, at this point, we've done the distributive property to get here. We're still not in simplest form, which is what the directions tell us to do. So if we put that in simplest form, we do so by identifying the terms that are alike. 6x plus 7x, when we add those, we get 13x. Well, the 7y, there's nothing to combine that with, so we're just going to have 13x plus 7y as our answer. This would be our final answer. Okay, on 17. Now we don't have the distributive property to use. There are no parentheses, so we know that we're not going to use the distributive property. What we need to do is to identify the terms that are alike, though. 10c. Okay, there's not another, well, there is another c right here. We have 5c. So those are like terms. I'm going to underline each of those once to remind me that when we're adding them, that those are ones that we're going to add because they're like terms. Okay, then we have plus 6d. I'm going to underline that twice. And underline plus d twice, because those are like terms. If you want to do different symbols, like triangles for the like terms, put a triangle under this one, a triangle under this one. Put a circle under this one, a circle under this one. You can put a rectangle, you can put a rectangle. If you would rather do that instead of the number of lines, then that's fine too. Just whatever it takes to keep straight in your head which ones you're adding when you're combining like terms. On number 17, 10c plus 5c. When we add those, we can combine them because they have the same variables. When we add them, we get 15c. 6d plus d. We can combine those by saying 6d plus d. Well, that's the same thing as 1d. So when we add that, 6 plus 1 is 7. So we get 7d. 15c plus 7d would be our answer on number 17. Moving on down, looking at 19. Okay, well, we have 7rs, 2rs, same variables and exponents from this term, between this term and this term, and another 3rs. Okay, so all three of those terms have the same variables with the same exponents, so all three are like terms. So we need to add all of the coefficients. 7 plus 2 is 9. 9 plus 3 is 12. So we end up with 12 RS. We know that our answer is in simplest form because once we're to that point, there are no parentheses and no like terms remaining. Moving on down to 21. In 21, 4.5v plus 23v plus v. Again, anytime you see a variable without a coefficient in front, you can assume that there's a 1 there. It's implied. Okay, so we identify 4.5v, 23v, and 1v, or just v, at all being like terms. When we combine these, we're going to say 4.5 plus 23, that's 27.5. 27.5 plus 1 is 28.5. So 28.5, and then remember your variable, which is v. We're just going to leave our variables and exponents unchanged. Moving down to 23, we have c squared plus 4d squared plus d squared plus 3d. Keep in mind that we have to not only have the same variables but the same exponents for two terms to be considered like terms. Looking at 23, I don't see any other c's after the first one, or c squareds. So there's not another term that we can combine that with. Looking at the next two terms, though, we have plus 4d squared. I'm going to underline this one twice and this one twice to remind me that those are like terms. And then we have plus 3d. Well, I need to underline that 3 times, or you can come up with a different system for doing it so that I can recognize that that cannot be combined with another term because there are no other terms that have just d as their variables. So the only things that we can combine on number 23 are the second and third terms. Keep in mind that we can pretend there's a 1 in front of that third, the front of that third term. So when we write that in simplest form, we're going to have c squared, since there's nothing to combine that with, plus 4 plus 1 is 5, so plus 5d squared. The 3d, there's nothing to combine it with, so we just need to add it on, plus 3d. So number 23 should be c squared plus 5d squared plus 3d. Okay, and then lastly, this one involves fractions. This shouldn't cause any extra confusion. We're gonna add and subtract fractions just like we do any whole numbers. First thing is to identify the like terms. A and 4/3 A are like terms. Just because there's a fraction doesn't mean that they're suddenly not like terms. If they have the same variables and exponents, then they're like terms. So underline each of these once because they have the same variable. Then we have 1/3 B and 4/3 B. Okay, when we look at those, they both have B as their only variable. That means that they're like terms. Those can be combined. Okay, so the ones that we're going to combine are the ones that are underlined in the same way. A, which is the same thing as 1A, 1A plus 4/3 A, when we add those, okay, at this point in life, if we're comfortable with adding fractions by hand, then add the fractions by hand. But if it's something that's going to trip you up, then make sure that you're comfortable with entering this in a calculator. 1A is the same thing as 3/3 A. So 3/3 A plus 4/3 A is going to give us 7/3 A when we add them. The B's, 1/3 B plus 4/3 B is going to give us 5/3 B. Don't forget our plus sign to separate them. Okay, at this point our expression is in simplest form because there are no more like terms and no parentheses.